Okay, well, hope everybody had a good 3-day weekend. I won't be recording long. We just had the focus activity. I'm going to give you as much time in the period as I can to go ahead and work on your assignment, which is due tomorrow. I will go ahead and work any 3 questions off the homework that you want me to go ahead and do so today. Tomorrow we'll also have our quiz over the solving trig equations, so go ahead and prepare for that. So hopefully these next couple of days, including last week, is just going to give you more practice for Thursday. What's happening? The test. Okay, so it's going to have double angle identities. There are 2 questions of those, and then the rest are going to be solving trig equations, all these different styles. Could be where you're just isolating a trig function, maybe substituting an identity, factoring, all these different strategies we've used. And then we just will continue on. Now, remember, next Friday is the end of the 6 weeks, so we don't have a whole lot of grades left. We're going to have the focus activities. You got your homework, quiz. The test is definitely the biggest one, so try to do as well as you can on it the first time around. Then let's worry about the retake. Okay, but let's get to our focus activity. It says a baseball leaves a bat with an initial speed of 30 meters per second and clears a fence 90.5 meters away. The height of the fence is the same height as the initial height of the batted ball. If the distance the ball traveled is given by d equals v naught squared times sine of 2 theta over 9.8, where 9.8 is in meters per second squared, find the interval of possible launch angles of the ball. So what we're talking about here, there's a small window where if these circumstances are true, the ball is the same height as the fence, and the ball is going to be traveling 30 meters per second. Well, from the horizontal when it hits, there is a small window, okay, where it's going to be able to clear the fence. So we're looking for a lower and an upper boundary. Okay, so we're going to be looking for this measure and then this measure as well, just to kind of give you an idea. Okay, well, we are solving an equation, but before we go ahead and start to solve the equation, there's something we need to do. Is the equation complete? Okay, do we know any factors? Okay, we know the initial speed. It was hit and is traveling 30 meters per second. Okay, so I'm going to go ahead and plug the 30 in there. And we know that the distance was 90.5. Okay, so let's say 90.5 is equal to, what is 30 squared? 900 times the sine of 2 theta, and we're going to divide that by 9.8. Okay, so this one, we don't have to do anything fancy. We'll just isolate the trig function. So what would you recommend I do next if you were solving this equation? I want to get this to sine of 2 theta equals. I'd probably go ahead and multiply through by the denominator, yeah, by 9.8, okay, because those are going to cancel. But what is 9.8 times 90.5? What is it, like 886.9 is equal to 900 sine of 2 theta. Okay, so sine of 2 theta should equal, and we have our ratio. We'll go ahead and divide through. So 886.9 divided by 900. There we go. Now here's the thing. Looking at that ratio, is it going to turn out to be a special right triangle? No. Okay, so we're not going to be doing this technically by hand. We're going to go ahead and use the calculator to help me out with this. So I'm going to take the inverse function. So sine inverse of this ratio equals 2 theta. Now, before we go to the calculator and we go ahead and get that, let's figure out our diagram here, because it kind of probably going to help us visualize what's happening. Because it's a positive ratio, what 2 quadrants will I draw my triangles in? Okay, we're close. 1 and 2. Those are where sine's going to be positive. So I'm going to have one triangle here, terminal side, terminal side. Okay, so there we go. Okay, come on. Oh, you done it? Okay. All right, so let's see here. We know that we're not going to be creating the triangles, but I just want you to visualize that we are still looking for two answers, because I remember our final answer is going to be an interval. Okay, in what degree range can the ball be hit, and it's going to go over the fence. Oh yeah, just put it in the tracer. Thank you. Is everybody okay with that? Okay, so now let's go to the calculator. Let's see what that is. Okay, so I'm going to click sine inverse. Ooh, interesting. Escape out of that. Control divide, was it 886.9? And we're going to divide that by 900. Oop, not 9,000. Okay. So what am I going to get when I push enter? Okay, so let's say about 80.2. Now, here's where we got to be careful. This isn't theta, this is 2 theta. So we'll deal with that in just a second. But this is the measure needed to give me the ratio that I was dealing with. So in the diagram, this right here is 80.2 degrees. Okay. That's what we're going to use to help me get my final answer. So how can I figure out what this other angle is going to be if this one has to be 80.2 as well? Subtract from what? You could do pi, if it was in radians, but in degrees, I would go ahead and take the 180 minus the answer we just got. So let's say 99.7. So this other one is 99.7 degrees. Now, if this were just sine of theta, we weren't manipulating theta at all, that would be my measure, but it is 2 theta. So I want to go ahead and take each of these. I know that 2 theta is equal to 80.2, and I know that 2 theta is equal to the 99.7. So what's this tell me for the first boundary? What's half of 80.2? 40.1 degrees. And then somebody help me out for the other one. 99.7 divided by 2. 49.9. There we go. That's got to be my interval. So if the ball is hit the same height that the fence is, okay, according to this formula, and it's hit at an angle between 40.1 degrees and 49.9 degrees at the 30 meters per second, it should clear the fence. That's a 4 right there. There we go. All right. So just a very small window and angle that the ball has to be hit at if it's going to clear that fence. Okay. So nobody has gotten this answer today. Did anybody have it prior to us starting? Okay. Did anybody get close? What I'm hoping is just because of the substitution, okay, we could have at least gotten the lower boundary. Did anybody at least get the 40.1 just by solving the equation? Okay, so a few people did. Good, good, good. But is everybody okay with how we did the rest? Okay. All right, well, whether it's going to be Friday or Monday, one of those 2 days, I'm going to have another focus activity, and then we'll turn in the rest of those next week sometime. Okay, so put that someplace safe. You got 3 of them now. That should be a guaranteed 100. Okay. And what I'm going to do now is go ahead and turn our attention to the homework. So I